day before yesterday on large whales' current status in the North Pacific. We're aware of the great success of the stoppage of commercial whaling on many of these great whale populations, and that's been a real success story. But of course, whaling, in a different sense, has continued in the U.S. and other countries in the form of this entanglement, unintentional killing of whales. And it's become a huge issue on the East Coast, as I think everyone knows, because of the right whale problem. But on the West Coast, to the surprise of some of us, maybe most of us, things have turned a bit sour for humpback whales, which have been increasing and still are increasing, but there are some serious problems here. And so that's going to be the focus of our talk today. We'll have a little bit of time as well to talk about the East Coast. But I'll introduce the 6 speakers this morning. First of all, Dan Lawson from the West Coast Regional Office of National Marine Fisheries Service. He's a fisheries biologist and has lots of information for us on the entanglement issue recently. Karen Martin from Southwest Fisheries Science Center will be talking to us about the stock differences. That's her specialty. Kelly Sace from the Strategic Earth Consulting Group is part of the California Dungeness Crab Fishing Gear Working Group, and she will lead a team of 3 people, right? Dick Ogg, a fisherman from Sonoma County. He's also part of that group that Kelly works with. And Dr. Jeff Shester from the California, he's a California campaign director and senior scientist from Oceana. Okay, they will be giving kind of a team presentation. And then Tim Werner from the New England Aquarium on the East Coast has been working a lot on entanglement and bycatch issues generally, and we'll be talking primarily about the right whale problem on the East Coast. And hopefully we can have some discussion of how the East Coast can inform the West Coast and vice versa. So when the presenters have given their presentation, we will have maybe a minute or so for clarifications if they've said something that can simply be clarified quickly, but we'll wait until all the presentations have been given before we have a actual question and answer session for about 15 minutes, hopefully before the coffee break. And then after the coffee break, we'll come back and have a panel session with a somewhat larger group, and I'll introduce that later. So without further ado, I think I'll turn it over to Dan to talk to us, and I'll let him tell us what he's going to talk to us about. Should be there. Okay. Use this thing.
Okay.
That's forward.
That's forward. And
The green is forward.
Okay, very good. All right, well, good morning, everyone. Certainly want to thank the Commission and Dennis for pulling together this panel today and this session. I think it promises to be a very interesting discussion. I'm going to really just give you sort of the background information on what we've been learning about entanglements here in recent years. I think you're going to hear a lot more about sort of what's going on and how we're addressing it. So I won't spend a lot of time in this first talk about that. Sort of in a nutshell, this is the story here. Looking at the graph on the board here, you can see that entanglements of whales and primarily gray whales and humpback whales have always been an issue and something that we've been tracking here along the West Coast. I came out here about 2008, and you can see we were sort of in that a relatively stable period of about 10 entanglements being reported per year. But the story has really changed starting in 2014, and that's really being driven by an increase in the humpback whale reported entanglements to us. I think the other main thing that's of interest here is that after never having a blue whale documented as entangled, we've started to get reports now in several consecutive years there. So in addition to sort of the straightforwardness of these numbers, demonstrating that something is going on and that there are some problems that we need to address. Certainly from our point of view as those who are collecting and trying to study this information, we've really experienced an increase in the demand in terms of the information and trying to making it available in terms of what we have learned and things like that. So there's really been an increase in awareness around this issue as well, sort of following along with the increasing activity. I think overall, we also have seen actually fairly significant advances in our ability and capacity to get information, out of these reports. So, I think we are seeing improvement in what we're able to learn going on. I think it's sort of an unfortunate consequence of getting a lot of practice here with all the reports that we're getting. But at least that's the good news is I think we are getting more and more better information. In terms of where the reports are coming from, and certainly I think most folks here are well aware that just where an entanglement is reported is not necessarily where it occurred. But from just a report point of view, you can see that we do have some similarity to the overall pattern of where entanglements come from, and generally entanglement reports come from places where we have a lot of people, so Central California, Southern California. That's over time, even before the recent years, that's been the relative pattern. Certainly with these years that you can see here, 2015, 2016 in particular, where we had really large numbers of reporting there, we certainly have seen concentrations of reports coming from the Central California area, and in particular Monterey Bay. Probably a lot underlies all that, and maybe most of all is that's just one of the most popular places, particularly to see a humpback whale. Regardless of where it may get entangled, it probably makes its way at some point to Monterey Bay. But we certainly are well aware of many entanglements that have been originated from this area as well. So in addition, another interesting thing that we had never had previously, and some of this is just sort of part of this ongoing development of our capacity, is we develop relationships with folks down in Mexico, and we're now starting to get reports from Mexico with whales down there, and during response, they've been able to identify some gear that's attributed with fisheries here in the U.S. So no real surprise, but just that we're starting to make those connections internationally to put the story together, which is really an international one and likely involves gear from Mexico, U.S., Canada, and potentially even beyond. With regard to the origins of these entanglements, I think the most troubling thing to me is the sizes of these slices of pie that are associated with unknown. I mean, the fact is the majority of entanglements we actually don't know the origin of. I mean, and that's really what sort of keeps me up at night and keeps me focused on what we can do to really improve that. Again, I think we are certainly still getting better at identifying the gear, but we have a long way to go, and I think there's going to be some hopefully steps coming in the future that may allow us to improve our capabilities even further, particularly relative to maybe some increased and more organized gear marking along the West Coast to identify fisheries. The other thing that jumps out here is that the predominant fishery that we do identify is the Dungeness crab fishery, in particular California Dungeness crab, but also gear associated with Oregon, Washington. I think it's interesting. We've actually been able to identify that recreational crab gear has been involved in some entanglements, and then certainly a handful of the other fixed gear fisheries. So particularly with respect to humpback whales, certainly from our point of view, we see this as really a West Coast-wide problem, a West Coast fixed gear fishery-wide problem. And while one of the reasons that we think that Dungeness crab gear is one of the most common ones that we identify is that it actually is relatively well marked in comparison to some other fisheries. There are tags that go on the buoys that are fairly distinctive that indicate, hey, this is a California, this is a Washington, this is an Oregon, versus the more just generic buoy, maybe with a marking. So, I think that's really contributed to our ability to identify at least the Dungeness crab fishery, and certainly that's got our minds thinking about the markings of some of these other fisheries as well. With regard to the blue whales, again, that's one where we just starting to recently see, and where we've been able to identify, it has been, again, the California Dungeness crab fishery involved there. Another thing I'll highlight here is we have sort of a general category that talks about nets, including gill nets. That's just been a really challenging thing for us to figure out. When you have netting on an animal, exactly where that comes from. We have gill net fisheries adjacent to us down in Mexico. So it's really just been a difficult one for us to figure out exactly which net and gill net fisheries may be involved in these entanglements, but another place where we're certainly wanting to put a lot of thinking to. For 2018, just as a quick update, and it had been a relatively quiet year, but we're starting to see some activity in terms of entanglement reports coming in, particularly in May. But it has been also a little different year as well. You can see we've had quite a few gray whales reported entangled. The humpback whales are just starting to show up in terms of entangled. Probably the biggest difference has been the amount of entanglement reporting activity up further north here in Washington. And certainly not entirely sure what may be underlying this as a change, but that's just been the reality of the season this year. And again, where we have identified the gear, Dungeness crab, again, as the most common origin that we've identified. All right, so in terms of what's going on, I think we still have a long way to go in terms of figuring it out, but we are starting to make, I think, some advances in understanding what's going on and what we're seeing. I think it's sort of safe to say it's quite a complex relationship between what the whales have been doing in these recent years, particularly how that relates to environmental variability and how the prey for humpback whales shapes up. We'll maybe talk a little bit about this later on in some of the other presentations about things that we've been focusing on in terms of looking at the whales' forage and how that may interplay with fishing effort. We're certainly aware of some changes compared to some more historical norms in terms of the distribution of the gear and how some of that's moving around. But in addition to all this, we think that public awareness is a big part of why we're getting so many more reports now. We've spent a lot of effort at the regional office in that regard, and outreach to the public, so I certainly hope that that's been effective. It's certainly not clear whether this is the level of entanglements that have always been occurring, and we were just seeing a much smaller proportion of it. So I think we're still trying to figure that part out. But I'm sure all of this is interplaying into what we're seeing in terms of the reporting activity. As I mentioned, we're certainly getting better at identifying the gear and understanding what it is, but the reality is we are still fairly limited, and certainly hope that we're not completely missing some other source, some other origins that we'd like to be focusing our efforts on as well. I don't know that there's anything particularly special about the Dungeness crab fishery and its gear. Certainly it is one where every trap has a line and a float at least on it, but it's really just the biggest fishery here on the West Coast by quite a large amount. The amount of gear in the water, the length of time that it stays in the water, things like that. So again, I don't know that there's anything real special about Dungeness crab gear. There's just more of it up and down the coast. And as someone who spends a lot of time looking at every one of these entanglements, the gear and how the animals are entangled, the short answer is we see just about everything you can imagine here, and all types of colors of lines and gear and arrangements of gear. So it's just really made it clear to me that it's not likely that there's just some easy fix sitting right out there that's going to solve this problem and make it go away. So, but certainly spending as much time trying to understand how the entanglements are occurring and what we can do, and perhaps little steps cumulatively together will end up in being able to make some advances here. All right, what we don't know, there's a lot of things we don't know really. Some of the key ones though that I think would be most important, again, these origins, not only in terms of the gear, but the locations of them. Specifically, it's fairly rare that we're able to really pinpoint exactly where an entanglement occurs, but certainly ultimately the goal would always be to focus any of our efforts to mitigate this problem on when and where we need to the most. So we really don't have a good sense of the total number of entanglements that occur. I think everyone appreciates that, the reports that we get are a bare minimum. So really unclear, particularly from a population level, what the impacts may be here. How does the whale behavior in these various gear configurations, contribute to the likelihood of entanglements? That there's still relatively limited understanding. We certainly look to the folks on the East Coast who've been studying this stuff for a long time, for insights and things like that. But still a place that we have very limited knowledge of exactly what constitutes or contributes between a whale encountering gear and ultimately becoming entangled. And then from a sort of long-term point of view, we actually really have, I think, a limited understanding of the outcomes of entanglements. We certainly, have a process in place for evaluating them, for purposes of the stock assessment. But, what, do these injuries, how long does the gear stay on? Again, a place where maybe on the East Coast, and there's been quite a bit more study, but, here on the West Coast, we're really in our infancy in trying to understand what are the sort of long-term outcomes from these entanglement events, especially for humpback whales here. In preparation for this meeting, I was asked to put together some information about how, okay, so we know all entanglements don't necessarily lead to mortality or serious injury. So I did some work here to put together some basic information. I think some of this may have been shared by the folks who do the serious injury mortality determinations and the stock assessment reports at the SRG meeting, but just sort of looking at where we think we are currently, relative to serious injury and mortality for some of these things. On the left-hand side there, I just took those numbers straight from the SARS, the most recent SARS for the humpback whales, and then relative to the 2016 entanglements and how those have been scored for serious injury and mortality. And then adding those together, and again, this is all very preliminary, and I don't want anyone to focus, specifically on those numbers. I think the general outcome of the story is that even with just looking at, entanglements of humpback whales, much less, any other sources, we are likely to be exceeding, the current PBR for humpback whales, up through these recent years. I also did some sort of quick math here in terms of looking at, the last decade or so of entanglements. The relative rate of mortality and serious injury is about 69%, and that's actually commensurate with what we saw just with all those humpback whale entanglements in 2016. When you look that out, it was about the same kind of rate that we're attributing from the stock assessment point of view. And then when we look at sort of what is disentanglement doing for us, again, as I did the math there, it looks like more or less about 13 humpback whales sort of saved from mortality and serious injury as a result of disentanglement. With regard to blue whales, we did have one mortality, serious injury in 2015, and then about 3.5 in 2016, at least in terms of what's been presented thus far in draft technical memos. So where is that really leaving us? As I just sort of mentioned, our sort of overall total here is likely to be in excess of the PBR for humpback whales the next time we complete a SARS for humpback whales. You can see the numbers relative to the blue whale PBR, which is quite low. We're heading to a place where a decent, significant chunk of PBR will be attributed to blue whales from entanglements when that SARS is updated. In addition to the PBR questions, I mean, humpback whales and blue whales are ESA listed, so that presents its own challenges for management of them. The next one, public perception, I think, and as much as anything, more so than even the regulatory side of all this, this has been the side of this issue that's probably brought us together here on the West Coast, the fishing industry, ourselves, and the idea that, no one wants to be a part of this. The fishermen themselves have plenty of interest in trying to address this problem because, this is beginning to become a little bit of a stain on this fishery that's long been one of the most sustainable ones, or the perception of that has been out there. So I think that's really front and center of what's been going on here to try and address this problem as much as any of the other regulatory things. And always want to point out that the pressure that's on our disentanglement response there is great. There was a death of a responder last year. Yeah, I think it was last year in Canada. I mean, I hope everyone always appreciates that. This is an extremely dangerous situation, and we really don't want to be trying to disentangle our way sort of around or out of this problem. I imagine most folks here are well aware of the fundamentals here of what can one do, and I think we'll spend a lot more time talking about this stuff throughout the panel. I certainly like to highlight the idea of this last one, get smarter, because that's where I spend a lot of my time trying to do in terms of understanding what's going on and filling in those knowledge gaps as best we can. And the final thing, again, I'll highlight, because I think we may talk about this a little bit more in terms of an ecosystem approach. I mean, from the NIPS point of view, and I think the point of view of the folks that we're working with here, this really is an ecosystem kind of problem. When we're looking at sort of what's going on with the whales, how they're responding to their environment, what's going on with the fisheries, how they're responding. So this is sort of just how we've sketched out, some of our research and analytical efforts, designed to get to the bottom of these questions and attempt to tie them together in a way that, we hopefully would be able to bring forward into the management arena in some aspect to try and address this situation. So, again, I think we'll talk probably more about some of this stuff as we go on today, so maybe I'll stop there. And
Thanks, Dan, and I don't see anybody eager to get something clarified yet, so let's keep going because we're running a little bit late. Karen, as you know, as everyone knows, the issue here is one of stocks, not species so much. And Karen's going to help us understand how stocks are being affected and which stocks of humpbacks and I think blue whales both are going to talk about both blue whales too?
That's
Good.
fine.
Okay. Thanks, Karen.
No problem. All right, thanks for the introduction. I'm going to hop right to it because I'm going to try and cover a whole lot in 15 minutes. As Dan mentioned, the three species that are being impacted are gray whales, blue whales, and humpbacks. I'm not going to talk at all about gray whales. There's just not time, and that's not a species where there's a lot of concern. I do have one slide on blue whales, but then I'm going to spend the rest of the time talking about humpbacks because that's where the biggest concern is and where it's the most complicated situation in terms of the biology of the animals. So blue whales are currently managed under the Marine Mammal Protection Act as a single stock. The eastern North Pacific stock, a single stock in the eastern North Pacific. And that ranges from the Gulf of Alaska to the eastern tropical Pacific. You can see there on the map the range of that stock within the U.S. West Coast EEZ. The estimated abundance is about 1,650 animals. And as Dan said, the PBR in the current stock is 2.3 whales per year. Total commercial fisheries serious injury and mortality in the current stock is reported as 0, but that reflects data from 2001 to 2013. So it does not account for this recent increase in entanglements. So observed entanglements, for example, just from 2017, there were 3 that exceeds PBR. Again, as Dan mentioned, not all of those will be deemed serious injury and mortality. But on the other hand, we know that there are likely to be a bunch of unobserved entanglements as well. So there is some cause for concern for this particular species and this stock, not only from entanglements, but actually also from other sources. Ship strike is probably even a bigger concern for this stock. So that's all I'm going to say about blue whales, mostly covered by Dan. And I'm going to jump right into humpbacks. So first of all, just want to tell you about how humpbacks behave in the area that we're concerned with. As I'm sure you all know, humpbacks are migratory whales. They spend the winters in low-latitude breeding grounds, which you can see here. This map is from data from the SPLASH project. I think you're probably all aware of that big project to assess humpbacks in the North Pacific about a decade ago. And using the SPLASH data and the YONA data and everything that they know about humpbacks, delineated 14 different breeding populations that you can see here. The feeding grounds, so those animals are in the breeding grounds in the winter. They spend the summers in the feeding grounds. Southern Hemisphere feeding grounds aren't shown here, but the northern hemisphere ones are shown up near the top in the little green circles. Zooming in on the area that we're concerned with, there are 3 breeding populations that contribute to the animals along the U.S. West Coast. The Hawaii breeding population is by far the largest breeding group in the North Pacific, with between 11,000 and 12,000 animals, and it is not considered threatened or endangered under the Endangered Species Act. It's recommended for not at risk. The Mexico breeding ground has about 3,000 animals in it, and it is deemed threatened under the Endangered Species Act. And then finally, the one that we're most concerned about is the Central America breeding population. The estimates of abundance range from about 400 to 800 animals. There's a fair amount of uncertainty there. Largely, these abundance estimates were generated by Paul Wade et al. Using the SPLASH data, but during SPLASH, they were unable to get permits to work in Panama, and we do believe that at least some of these animals, these Central America animals, are in Panama, and they just weren't able to collect any data. So that might be a bit of an underestimate, but regardless, we know this is a very small population. And then you can see the feeding grounds that we're concerned with. The one that is of greatest concern, where most of the entanglements have been occurring, is this California and Oregon feeding ground, which has an estimated about 1,700 whales. And all of the animals in the California, Oregon feeding area are coming from the Mexico and Central America breeding populations. In fact, nearly all of the Central America animals go to the California, Oregon feeding ground. Those dashed lines show migratory connections between the breeding and feeding areas. There are a very small number of Central America animals that go to that northern Washington, southern BC, but it is a very, very small number. Almost all of them are off the coast of California and Oregon. And you can see that a little more clearly here. This shows photo ID matches from the SPLASH data between the feeding areas, which are along the left, and then the breeding areas along the top. And so if you just look at this, let me see if I can get my cursor over here. For Central America, there were 26 matches to animals from California and Oregon, 3 matches to animals from northern Washington and southern BC, and that's it. They're not seen anywhere else. The Mexico animals, you'll see they're divided into 3 columns here. That reflects some level of uncertainty about population structure there in Mexico. The Mexico mainland is probably a distinct breeding group from the column 4, the Mexico Islands. That's the Revillagigedos. So there's some debate as to whether or not those are actually different breeding populations. And then Baja is kind of a mix, because animals from Mexico mainland, Revillagigedos, and Central America all migrate through Baja. So there may not be any animals that actually feed off or that breed off of Baja. But again, you can see the Mexico animals are spread more broadly from California all the way up through the Bering Sea. Oh, and I also want to point out that if you look across for California and Oregon, there are no matches outside of Central America and Mexico. They're all coming from there. So these breeding grounds and feeding groups are also genetically distinct. These pie charts show haplotype frequencies from 400 base pairs of mitochondrial control region sequence. And if you first look just at the breeding grounds here, you can see they're very different. Central America is dominated by these blue and green haplotypes that are in much lower frequencies in the other breeding areas, whereas Hawaii is dominated by these A-type haplotypes, which are completely absent in Central America, for instance. And then again, the feeding grounds, you can see up near the top, again, just looking at them visually, they're very different from each other, and they tend to reflect the haplotype frequencies of the breeding grounds that are feeding into them. So California and Oregon, again, has a very high frequency of those blue and green haplotypes that are dominant in Central America. So that gives you a sense of how the animals are, the connections between the breeding and feeding areas, but even within feeding areas, there are gradients in terms of the different breeding populations. They're not evenly distributed. So Central America all the way to the right there, you can see well, let me back up and say the rows are finer spatial scales within the feeding area. So the top three, southern BC, inland Washington, and Washington Outer Coast, that's that northern Washington and southern BC feeding area. And then all of the rest of them are within the California and Oregon feeding area, and they're ordered from northernmost at the top to southernmost at the bottom. So if you look all the way to the right, you'll see in Central America, even within the California and Oregon feeding group, the Central American animals are concentrated in the central and southern California region. So even within that feeding group, your probability of bumping into a Central American whale varies depending on where you are within it. And that is, here's just another graph kind of relaying that information. This shows it from a genetic perspective, graphing the frequencies of just 4 of the most common haplotypes. And so you can see this blue line is the dark blue haplotype that's very common in Central America. It's in high frequencies near the US-Mexico border and then steadily declines. And then this line is supposed to match this sort of yellowish color. It does on my computer screen. And so this is one of the haplotypes that's dominant in Hawaii. It's almost completely absent in southern and central California, and only starts to become more common as we get closer to like Washington and southern BC. So again, just showing the latitudinal gradients even within feeding areas. So that gives you an idea of what the animals are actually doing, how they're moving between feeding grounds and breeding grounds and within them. So now just to talk a little bit about the management challenges that we face. The stock that we currently are managing under the Marine Mammal Protection Act is not correctly delineated. The humpback SAR, like most of them, were written when the Marine Mammal Protection Act amendments came into place in the late 90s, and they just put all of the California, Oregon, Washington humpback whales in a single stock. Since then, we've learned a lot about humpbacks, and we know that there's a whole lot more structure in there, but those stocks have not been updated. So we have one stock that we know contains animals from the endangered Central America population, the Mexico mainland, Baja, and Revillagigedos populations, which are collectively threatened, and in the northern part of the stock, we have animals from Hawaii. We really can't monitor or manage the impacts on these different populations until they're separated out into different stocks. We're working on that. There's a working group that's been convened to update the stock delineation. That effort is currently on hold and has been for, I think, at least a year now. While the agency works on, NIMS headquarters works on a revised policy on stock delineation. And so while they're working on that policy, there's a nationwide or agency-wide moratorium on stock delineation revisions. So we're ready to move forward on this revision, but we really can't do anything yet until that policy is finalized. And as far as I know, there's no timeline yet for when that will be finalized. So the way we're managing them currently, as I said, is in a single stock, and there you can see the range of that stock. It's basically the same as the blue whales. It's the West Coast EEZ. Estimated abundance just under 2,000, PBR of 11 whales. Total commercial fisheries serious injury and mortality in the most recently published SAR is 5.3 whales, but again, this doesn't account for the recent increase in entanglements. So I won't go through this much. Dan discussed the fact that the entanglements have gone up a lot. He actually had more information about how they've been assigned serious injuries and mortalities. So definitely the serious injury and mortality just from entanglements is almost certainly exceeding PBR for this large stock, which we know actually contains multiple populations. They asked me to just talk about data gaps, and so I'm kind of couching that in terms of gaps that are impeding successful management for this species in this area. Again, as I said, the current stock delineation is incorrect. We know that there are at least 2 distinct population segments. That's the ESA level unit that inhabit this area. probably more than that when you get down to the demographically independent population level, which is what's relevant to the Marine Mammal Protection Act. Yet we're currently managing them as a single stock. Our existing population level abundances are out of date. Those are the abundance estimates for the breeding populations, and the only data we have to make those estimates at this point is the splash data, and those data at this point are too old to be used in the stock assessment reports. We also need better data about the relative abundances of these animals by latitude within the feeding areas, and we currently are not able to reliably assign mortalities to the breeding populations. Now, we do have research underway to address all of these issues. I'll just go through real quickly what we've got going, but there is certainly a lot more work needed. There we go. So in terms of what's going on right now or planned to happen in the very near future, there are 11,000 new photo identifications from the last 2 years that are currently being added to the photo ID catalog. This is work that Cascadia Research Collective is doing. This is a huge increase. The current catalog size is about 25,000 identifications, and they're adding an additional 11,000, so 50% increase in the size of that catalog. And these new identifications include quite a bit of data from some of the breeding grounds. So this should really help us to better understand those connections between the breeding and feeding areas. We have a pilot project. Oh, I should also say on the photo identification, as we get more photo IDs from the breeding areas, that increases our ability to assign animals seen on the feeding ground to a breeding ground if we can actually photo ID and match them in the catalog to an animal from the breeding area. We also have a pilot project that's just about to start, trying to improve our ability to assign samples based on genetic data, expanding the genetic data set in order to do that. And then we have a large survey that's about to start, the California Ecosystem Survey. This is a survey led by Southwest that's unique in a few respects compared to our previous surveys. First of all, it's going to have much greater effort in the nearshore habitat, and you can see in the map there the track lines, the planned track lines, and you can see they're very dense and very coastal. So we should be getting humpbacks really well in this survey. The focus will be on obtaining photo ID and biopsy samples from humpbacks, and that's going to be facilitated by Cascadia Research Collective, who we have contracted to conduct simultaneous shore-based small boat effort. So we'll have the big NOAA ship out there running the track lines. When they see humpbacks, they'll radio the Cascadia crew and say, hey, there are humpbacks over here. And then the big boat can keep going, and the small boat can go in and spend the time to get the photos and the biopsies. We'll use those data to assign individuals to breeding populations, and then the resulting data can be used to develop population-level metrics for the different breeding groups, abundance, distribution, entanglement rates based on scarring in photos, hormonal analyses, and so on. That's it.
Thanks, Karen. I'm sure we have questions, but let's hold them if we could, because we're running a little bit late again. Now it's up to Kelly and her team to make their presentation in the way she decides or they decide. And we're going to talk about mitigation now, which is a separate topic in a way. And so
we're going to see if you don't mind.
You're going to sit there? That's fine. Yeah,
That'd be
sure.
awesome.
Okay, right.
And,
You need that, don't you?
We'll be here. I don't know if we need to switch out microphone.
Yeah, okay.
I have to hold it down the whole time? Oh, that's going to be so great. We're going to do this together. It's going to be fantastic. So as Rainey is putting up the presentation, just want to thank the Marine Mammal Commission so much for having us here. Apologies for folks who are on the far, in our left, your right. Just know we're looking at you and we can see you through the podium. And this is just an effort for Jeff, Dick, and I to give a presentation collaboratively in the spirit of the California Dungeness Crab Fishing Gear Working Group, which in itself is a collaborative group. And we thank you for your patience. If this approach does not work, you can tell us in the future, and we will do it differently. Thank you. That's very helpful. Thank you so much. So I'm going to just start. Thank you so much. We'll just start and with some introductions. And so maybe, Dick, would you like to introduce yourself first?
Certainly. My name is Dick Ogg, and I am a commercial fisherman from Bodega Bay. I've had the opportunity to fish up and down the coast there for roughly 50 years. I have the boat Karen Jean, and I'm here to try and give you a fisherman's perspective.
My name is Jeff Shester, and I'm with the conservation group Oceana. For those of you who don't know, Oceana is an international conservation organization. We have offices in 11 different countries, work on many issues regarding fisheries, bycatch, habitat protections, as well as preventing oil drilling off of the West Coast and seismic testing in the Atlantic. I think we were very surprised in 2014 of the level of whale entanglements, and I think we saw that the fishermen were motivated from the start. I think that this fishery has been proactive in solving many problems before even the whale entanglement came up, and we saw that, and we basically were excited to see if we could try kind of an experiment with a new approach in this working group that could combine our collective expertise with some of the fishermen and actually try to solve this problem through collaboration.
So we are going to tag team in hopefully a very seamless way. So we'll just start. My name is Kelly Sace. Myself and my colleague, Rochelle Fisher, have the real privilege and honor to help administer and facilitate what we'll call the working group, the California Dungeness Crab Fishing Gear Working Group. We've been working with them for the last 3 years and really excited to be here. So thank you for having us. I'm going to give a brief background sort of overview on the working group. And maybe I should just say up front that our presentation on a whole is sort of overview-esque, and look forward to diving into more details as need be during the panel discussion and certainly Q&A. So in response to the recent increase in whale entanglements that now Dan and Karen have talked about in their presentations, the working group was convened to help the state address this really complex and challenging issue, and just to acknowledge that the working group itself was convened by the California Department of Fish and Wildlife in partnership with the California Ocean Protection Council and the National Marine Fisheries Service, and is a collaboration of commercial and recreational fishermen, environmental organizations, disentanglement experts, and researchers, gear manufacturers, and then has this level of advisorship, Dennis Heineman being one of our advisors, that helps to bring together this group. And there's really this shared vision and mission that the group has in supporting thriving whale populations together with supporting a thriving Dungeness crab fishery. And through their work, this group, their intention is, and that they have already made recommendations to the state on how to manage and mitigate this issue. One of the things right from 2015 when the group was brought together, it was very sort of clear at that time, and as Dan articulated earlier, that there's so many more questions and answers as to the nature of entanglements. And the group coalesced with certainly asking questions about this theory of co-occurrence, of the relationship between high concentrations of whales and high concentrations of gear, and what that means in terms of the potential risk of entanglements, and wanted to test out that theory through a number of information gathering projects that focus on gathering information about whale distribution, gathering information about fishing effort, as well as technologies that can be used to help learn about both. And so we'd like to spend a moment, I'm going to pass the microphone over to Dick, to talk a little bit about some of the information gathering that the working group has done thus far. Sorry.
Okay, I'm going to just read this here so I can be fairly clear. The development of the best practices, which we're talking about at this point, it was a collaboration of the full working group's effort to minimize the opportunity for entanglement with Dungeness crab gear. And I personally believe that the thoughts were to focus on a way that we wouldn't impact the process of our operation and not have a big financial impact. And that was really critical. So we concentrated on what we thought was somewhat obvious, And it seemed to us that the surface gear was the lowest hanging fruit. Floating ropes and so on and so forth. As a result, we kind of analyzed the buoys and the length of trailer ropes behind the buoys, and tried to figure out a way to minimize the lengths and so on and so forth. The distance between the buoys became, something that we felt was fairly obvious, that we needed to minimize that distance. And so based on depths, we decided that 2 buoys in a certain depth would be adequate, 3 buoys in a certain depth would be adequate, and minimize the distance between the buoys. It's certainly not the answer, but it's in my opinion, kind of baby steps towards bigger resolving a problem, a bigger issue. In reality, to be honest with you, most of the fleet more or less practiced the best practices. I really feel like, that we've made a serious effort to try and follow those kind of rules and guidelines that the working group has put together. And I hope that that has had a little impact on the decrease in, California Dungeness crab entanglements over these last 2 years. I know there's a number of other factors involved, prey distribution, water conditions, and so on and so forth, but I truly believe that the fleet is trying desperately to, help resolve these issues. And currently the California Department of Fish and Wildlife is taking these recommendations and utilizing them for a rulemaking decision, and that should be out sometime in June. So anyway, thank you.
Do you want to keep on chatting about the ropeless gear? I mean,
Oh.
the tool logger?
Oh, yeah, I'm sorry. Okay. Okay, I've had the opportunity to, let me make sure I don't forget anything here. I've had the opportunity to work with a number of different devices to inform the dynamics and the behavior of the fishing fleet. One such device is this solar logger. You can see it on the right-hand side of the slide there. It's a small device that we've been working with the Pacific States Marine Fisheries Commission, gathering data and generating these heat maps, which show fishing effort and can be overlaid by prey distribution and whale concentration maps. The advantage of this solar logger is that it's completely passive, and we as fishermen don't have to interact with it at all. It basically says or shows, as you can see on the one slide there, that's my track lines. And there are approximately 12 vessels, that have volunteered to, test this piece of equipment. And given the information that you can see there, you would be able to see the fishing effort. And it's nice because, as a fisherman, I can't be pushing buttons and trying to manipulate things while I'm trying to run gear. It's just impossible. So currently there's a request for additional funding to upscale the project, and I really feel like this information, can help inform us of, potential severe situations if we need it. So, thank you.
Yeah, and I think just to
No, you're doing great. Oh, yes. Sorry, this is a bit of a dress rehearsal too, so thank you all again for your patience. So in having this conversation, Dick outlining a few of the projects that the fishermen have really helped to lead, one being the best practices guide, the other the solar logger data. Another type of project that the working group helped to initiate was to work with a researcher out of UC Santa Cruz, Dr. Jared Santora, and he was instrumental in helping to synthesize forage data. So this understanding of where forage our whales go, again, with this focus on humpbacks. And it was a really, it's been a very eye-opening and really instrumental part of the conversation of the working group. And so as part of this conversation, I am not a forage expert, so please know as I sort of summarize this, that the data focused on 2013 to 2016 information. Again, as Dan mentioned, that sort of as whale entanglements were starting to increase, with this understanding that starting in 2013, this record upwelling that had been taking place, there became this anomalous warm sea surface temperature trend that happened, otherwise known as sort of the blob that we have all chatted about. And that this then spurred a decline of krill abundance, where krill, as I understand it, are typically more offshore in the canyons. They were less available. The humpbacks switch feed, and so made their way more inshore, chasing anchovy, which were found in higher concentrations along the shelf. And that this started to really happen around the 2015, 2016. And it's a little bit tricky because whales are looked at over a calendar year. Dungeness crab fishing is across 2 years. So they start fishing in 1 year and end fishing in the next. So looking at the 2015-16 fishing season, we also had this circumstance where domoic acid was high concentrations at the highest levels yet that have been recorded. The fishing season itself, a commercial fishing season, was delayed until March. And you had this real unfortunate overlap of really unfortunate circumstances where you had a lot of whales inland fishing. Well, they were fishing. They were eating anchovy. And a lot of fishermen arriving. They hadn't been able to fish since November, so ready to get in the water and be able to pay their bills. And were fishing right on top of a lot of whales. Also, the crab distribution was such that it was very much in the central California area, particularly off of in the Monterey and a little bit north area. So it was this real unfortunate circumstance of events, and that information has helped the working group to be thinking about, all right, so what are those factors that contribute to an increased relative risk of entanglements, and that has been able to focus in the working group's attention, and then has led to the building of a risk assessment and mitigation program. And so this program is something that is new. It's been piloted the current season, the 2016-17 season. And the working group started to think about, all right, so what are those conditions, forage and ocean conditions, whale concentrations, fishing dynamics, such as delays, the ability to transition to other fisheries in the spring, going from crab to salmon, which a lot of fishermen that fish Dungeness crab also fish commercial salmon, as well as the rate of entanglements that are occurring as well. And so this idea that under these elevated circumstances, there then needs to be a focus of attention and a mobilization of experts, including fishermen, environmental organizations, researchers, agencies, of course, to understand what is happening under those certain circumstances and to come up with a strategy to address them. And this diagram is a little overwhelming, so please, I'll just try and stay at a high level, but it's in an effort to show that on the far left-hand side, under these certain circumstances that may elevate risk, delay, that's sort of been updated to fishing concentrations, forage, whales, and entanglements. If any of these factors a flag is raised, if any of them, and there are criteria that help to determine how that flag is raised, which we can go into as it's helpful, you then make your way into it sort of like a stoplight system of low, moderate, or high risk, which then helps to inform the working group's discussions on what information should be gathered, and also or what information can be gathered, as well as what management measures may be options to consider under those certain risk circumstances. So again, this is still in its pilot phase, but this is part of what the working group is really focused on. So Jeff is going to speak a little bit about some of the information gathering that's happened during the pilot project.
Yeah, so, and I think what's really driven a lot of the working group's efforts and this RAMP program Kelly talked about is that trying to get information on the spatial and temporal overlap of fishing gear and whale concentrations. And so we looked at various tools, and one of them is looking at the idea of aerial surveys, so actually flying over and doing transects over the ocean from an airplane, and basically building on the existing whale survey methods that NIMS and other researchers currently use. And the question was, can we expand these to actually simultaneously not just look for whales, but also evaluate fishing effort distribution with crab traps, since you can actually see buoys from the air. And so you can see down in the lower left, that's kind of a zoomed-in photo, but you can see these buoys then from the air, and basically similar to how whales are counted, look at the various angle from the field of view and actually determine both the distribution as well as the total density of traps in certain areas, and get total counts based on the statistical methods that are used for these aerial surveys. So we did a pilot in 2016 to try this out and see if we could do it. And in fact, we got some really good data that actually showed that in Monterey Bay where the traps were, and particularly the depth distribution was really interesting. And so we decided to build on this at the beginning of this last fishing season in November, when there was still a high or moderate level of whales being observed in Monterey Bay right at the time when the crab season was beginning. And what was really interesting about this is that whale watching community was seeing a lot of whales, and the fishermen really weren't seeing that many. And so this aerial survey, as you can see, kind of indicated to us that, in fact, yes, there's, you could see where the traps are and where the whales are, but you can see some of the blue whales, the blue and then the green rectangle, or the green triangles there were where the whales were sighted, and you can see those were actually in places that had relatively less fishing effort. And this helped, I think, prompt our group to reduce that risk level from that yellow moderate down to a green, but still provide information to the fleet about what we were seeing. So this is, I think, a useful tool that actually in real time tells us both where the whales are and where the fishing gear is, rather than using two different sets of data to try to get at those that might not be matched in space and time. Next slide. The other, I think, really exciting project that I was personally able to be involved with is looking at the ropeless fishing gear idea. And so the idea with whale entanglements in general is that it's the vertical lines and the buoys and the surface gear at the surface that is really causing the risk to whales. They're getting entangled in that. And if you can actually fish for crabs and use these traps without a vertical line being there, that could actually reduce or potentially even eliminate the problem altogether. We were aware of efforts that have happened in other places. Woods Hole recently held a workshop on this, and we said, hey, can we get our hands on a few of these existing technologies and put them in the hands of a few fishermen? So Dick and two other fishermen from the Central Coast, we went out basically for a day, and we got one of each of these systems and put them out. And basically, we saw that there's a learning experience that could happen. I think we saw a lot of potential there. I think there is a potential to bring this into some of the higher risk areas, but there is also a lot of costs and the need to actually make sure that these systems are integrated with the West Coast fishing methods that are out there. And so I think we identified certainly some important next steps that could be taken. For example, scaling this up so that you could actually have a larger number of fishermen try out a whole set of these, not just for one day, but over the course of several weeks or months, to actually see can they try different configurations out and really reduce the extra time that it takes to use these systems, reduce the potential for the loss of these. We did have one of these systems not actually pop up, so there's always risk there, and I think we recognize it's kind of a learning experience. But one interesting potential here is that if there are high-risk areas that need to be temporarily closed to reduce whale risk, there's I think an interesting idea is that that potentially fishermen could still fish if they use ropeless gear in these areas. And that could provide a financial incentive to help pay for some of the costs of some of this equipment. So that, I think, in addition to looking at other questions like how do you enforce this, if you can't see where the buoy is, how is enforcement and management and other fishermen going to be able to know where the traps are? These are key questions that I think we can answer. But I think the benefit is that we've started this I think in a collaborative way and partnering up. And I don't know, Dick, since you got to try some of these, if you have any short, quick thoughts on this. I see we're running low on time here, so we're going to need to wrap up. But.
Actually, not much. I just have to say that my main concern on something like this is reliability. The loss of the gear can be substantial, especially if we gang these pots together, which is what I would assume we would try to do with a lot of the ropeless gear. But I do see a good potential, and I really hope to keep following up on this.
Thank you. And I will help us to wrap up, too. So just to say out loud briefly that there are continued coordination that's happening with the working group over the coming months and potentially beyond, a number of other evaluations that they're continuing to do, and continuing to fine-tune all the things that we're talking about in terms of data gathering, in terms of the risk factors, those 4 factors, in terms of the management responses, the measures that may be plausible or appropriate related to various levels of risk. So that's continuing to be conducted by the working group, and the evaluation of the pilot itself, and then the intention that for this upcoming season, again, recognizing we haven't finished the current season, but for the 2018-19 season, that sort of a ramp 1.1 will be available to continue being implemented. There is additional research that's being conducted in terms of some modeling, taking the forage data and overlaying that with some of whale models that exist. Karen Forey out of the Southwest Fisheries Science Center is spearheading that. And maybe, Dick, we'll pause on the gear recovery, the gear recovery and the smart buoy prototypes we can certainly circle back to during the discussion as folks are interested in other efforts that are being conducted. And then I think one thing to just highlight, in addition to the fact that there are other working groups that are modeled off of California taking place in Washington and Oregon, we also have some current legislation that California is moving forward. And there's a Senate bill that includes 2 components. One is to move forward an idea that the working group had. As was mentioned earlier, a great percentage of the entanglements that occur the gear that's involved in those entanglements is not well known. One of the reasons why Dungeness crab is here is because they have buoy tags and gear markings in a way that are identifiable. Not the only reason, but certainly there's a number of reasons, but that is one of them. And so increasing identifiable gear markings is something the working group thinks would be a really important advancement and something that is in this legislation. And then the other is to take this concept of the ramp and to implement it with fisheries managers. And so looking for authority for the department to be able to implement the ramp in a meaningful way. So pause there. Thank you, everyone, so much. This is the working group in action. They're an incredible, incredible group. Thank you both for tag teaming, and thank you for your patience as we tried out a new way of presenting to you all.
Thanks, Kelly, and guys, I'm sorry to push you like I've had to, but we're running late, not as usual, but it's not good. And we want to hear from Tim from the East Coast and then have some chance to discuss and have questions, which I think there are quite a few of. So as soon as I get his presentation up, I'll get Tim to start his talk. Okay, go.
Thank you. Good morning, everyone. Thanks to Dennis and thank you, and to Dan, and to the Marine Mammal Commission for the invitation to come out here. I bet you all thought you were escaping East Coast whales at this meeting. No such luck. But it's a tremendous opportunity, especially for me. I think anytime we have these cross-learning opportunities, it's really worthwhile to do. So I'm going to talk about mitigation efforts of large whale entanglements in the Northwest Atlantic, especially focused on the North Atlantic right whale. This is a species largely now restricted to the Northwest Atlantic, Florida north to the Canadian Maritimes. The current population estimate is it's now fewer than 440 individuals, with 105 breeding females. Since 2010, calving rates are down 44%, and we saw no mom-calf pairs observed during the current high season in 2018. At the same time, the incidence and severity of right whale entanglements is up since the mid-1990s, and entanglements now surpass ship strikes as the main source of anthropogenic mortality. And just a reminder, entanglements result in direct mortality, and through recent studies show that they also reduce the reproductive capacity, really a function of the energetic cost in producing offspring. What a difference a year makes. In 2016, we had a pronouncement from the agency that we're making significant progress in reversing the population decline of the North Atlantic right whale, and that we're seeing signs of recovery. Then 2017 comes around. We have a study showing, hang on, wait a minute, entanglements are hindering population recovery. We had 17 mortalities in Canada and the U.S. combined. Since then, the Atlantic Large Whale Take Reduction Team, which is convened by NOAA, has established multiple working groups, a lot of meetings. There's been a lot of press attention. There's been lawsuits from the NGOs. The Department of Fisheries and Oceans in Canada has instituted new fishing restrictions and mobilized a lot of funding for mitigating entanglements. So a real big turnaround in 2017. What I'd like to do is review some of the strategies briefly for mitigating right whale entanglements, but focus primarily on right whales. Talk a little bit about some current gear research and then some concluding remarks. I'm guessing this is hard to see, so I'll run through it. What I've done is I've listed some of the mitigation techniques, talked about what they are, whether or not there's evidence supporting that they're effective, or evidence to support rejecting them, and then finally whether or not there's evidence lacking for them. So the first idea involves minimizing the ratio of vertical lines or buoy lines to the units of gear deployed, which is also referred to as trawling up. On the East Coast, of course, we have a lot of multiple traps connected by ground line. Not so familiar out here, I know that. There is one unpublished study by a colleague of ours at Woods Hole showing that sightings data and records of fishing gear deployments did show that encounter probabilities were reduced. By how much, I can't exactly say. At the same time, however, we know from working with fishermen that when they went to longer trawls in order to reduce the number of vertical lines, they also went up to larger diameter ropes, which we found is associated with higher entanglement incidence and severity. So there's a trade-off there. Reducing rope or net length, this is frequently cited in different pot fisheries around the world as a potential thing that seems intuitively obvious, and yet there really isn't any evidence to support if it works or not. We don't know where in the water column often a lot of these entanglements are happening. It's difficult to quantify. It can also lead to higher line tension, which can increase the severity of an entanglement, at least on the East Coast where we have really strong currents. But there could be some reduction in injury severity if there's less gear being dragged by the whale. So if you reduce the length of rope, then you have less drag if the whale becomes entangled. Reducing wet storage of gear makes intuitive sense. However, you still have, at least on the East Coast, gear that's sitting in the water for multiple days. So it's not clear how to quantify any benefit from that. There's a mandated, it's regulated that buoy lines be negatively buoyant in the water column at the upper portion of the buoy line. Again, it assumes that entanglement risk is highest in the surface area. And we don't have any evidence whether that's the case or not. Did I advance? No, I didn't. There's been some really interesting work, especially with right whales, on response to different colored rope mimics, and also some genetic work showing what sort of, what the visual perception is in right whales. Scott Krause et al. Are currently working on a paper showing that ropes in the red, orange, and black hues tend to show more of a response than white, green, or other colors. However, that was done in surface waters in the daytime. We don't know how that would work at depth and also at nighttime conditions. And that's right whales. We know that humpback whales, which is a lot of what we're talking about here, there are anecdotal reports that they like to play with gear a lot. So even if you visually enhance ropes so that humpback whales are better able to see them, what is the behavioral response? Are they going to go, oh, cool, I want to go get entangled in that or play around with that, or no, I want to avoid that? There's just too many unknowns there. There's been some recent work looking at acoustic pingers to show if there's any area deterrence effect with humpback whales, and those have shown no avoidance response. There's been a lot of talk over the years about making ropes stiffer. If they're stiffer, they have a reduced entanglement property, and therefore will whales be less likely to become entangled. There's been several studies, including one we supported with engineer and a fisherman up in New Hampshire, and what we noted was that there seems to be a trade-off between reducing the entanglement property of the rope, but also increasing the potential of the rope to cut into a whale at a certain diameter. So you might get fewer entanglements, but the entanglements that result could result in more severe injury and therefore increase the mortality from the event. And there's just a question in our region if you can even maintain a rope stiff in the water column because of the changing tides and currents that you encounter there. There's been talk about reducing, the NOAA fisheries encourages fishermen not to use knots but to use splices. They use knots like crazy anyway. But on the one hand, the basic rationale is that the knot would, if a whale got entangled in a rope with a knot in it, the rope would slide along the whale. The knot would become lodged in the baleen or an appendage, and therefore that would increase the probability of the whale becoming entangled. If you make it a lot smoother transition, then that would be less likely to occur. We don't really have any evidence to support or reject that idea, but I do note that as we look at reducing the breaking strength of ropes, when you put a knot in a rope, it reduces its breaking strength roughly by half. So fishermen have come back to us and said, wait a minute, what if we just, if we want to use weaker ropes, why don't we just tie knots in it? It could be a simple way to get at this solution. So it's something that requires more examination. And that leads us to this idea of self-release in a reduced breaking strength rope, which we have evidence to support by looking at gear retrieved from disentangled whales in the Northwest Atlantic. And our results from a paper we published in 2016 suggest that ropes of reduced breaking strength, 1,700 pound force or less, would be less likely to entangle adult North Atlantic right whales. Time area closures I just want to talk about briefly because they're sort of the default option for us around the world. If we have a problem with interactions between protected, endangered, threatened species and fishing gear, the idea is, well, let's just close off the area, something that fishermen generally don't like to do. And it includes restricting the types of gear within those areas, and more recently, it includes what the Canadian government is using as real-time trigger closures, that as they're monitoring the presence of right whales, for example, in the Gulf of St. Lawrence, if whales come in, that they would make efforts to stop fishing until the whales leave the area. There's been a lot of studies on protected areas, but not really many having to do with bycatch of protected species. And when you look at the papers that did look into that, they basically conclude this, that to conserve or recover a species or population, these areas need to be large enough, located in the right areas, effectively managed, avoid introducing new threats, and established at the right times. And so it's really quite challenging. You're certainly within a particular area, if you don't have gear in the water, you're not going to entangle a whale. However, the minute the whale leaves that area, all bets are off. And we know that whales become entangled all over the place, up and down the eastern seaboard of the U.S. and Canada. So how large would such an area or network of areas need to be really be effective remains to be answered. So there's this lightning rod issue of ropeless fishing. I'm glad to hear that you're playing around with it out here. You're familiar with it, so I won't describe it, but it's something that's very much being actively tested, not just out here, but in Canada and the U.S. right now. It's already being used in Southeast Australia. There have been multiple evaluations in the Northeast U.S. with reliable results, not always reliable, but some reliable results. Of course, there are longer-term issues to resolve having to do with cost and gear conflicts. This is no quick fix, but the most important thing for us to make progress is to get this stuff in the hands of fishermen and start to have them testing it, and to engage the agencies that regulate fisheries to tackle some of these problems of gear conflicts. We're also working with reduced breaking strength ropes or whale release ropes, and this is based on the study I referred to earlier. We've deployed these out in Massachusetts, New Hampshire, at different depths and different lengths of string pots ranging from 1 to 20. Different fisheries, lobster, whelk, black sea bass, but all pot fisheries. And we're currently analyzing that, working on a report that'll be due in July 2018. Conclusion then. Thank you, Randy. I think it's really important that as we look at some of these mitigation efforts that we're examining the evidence to support or refute them, or where we actually don't have any evidence at all, and to be wary of assumptions or what we often call best practices. Some measures may work, but the extent to which they reduce entanglements may be insufficient to sustain or recover the population. In other words, the contribution could be a very small percent and not sort of our target, and not our target. And it can come with other consequences that create other entanglement risks. I mentioned trawling up. We reduce the number of vertical lines, but then we increase the diameter of the lines. Is there a net cancellation of that? I don't know. Also, I think the process that you engage in depends on how the level of endangerment of your target population. How many years do you have until the brink of extinction? Urgency influences the kinds of strategic decisions you make. If you're dealing with something that's really critically endangered, you don't have a lot of time to do the back and forth. Well, let's try this idea, implement it, monitor the population. Well, that didn't work so well. Let's try this idea. You start getting down that slippery vaquita slope that we've all watched happen. Local circumstances are highly relevant, whether or not the gear is appropriate in inshore versus offshore, geography, west coast, east coast, different kinds of gear. You really need to look at that in each instance. And I'd just like to encourage us to create this not just domestic but international learning network with Canada, with Australia, with South Africa, to look at what's working, what isn't, what's promising, and what are the research priorities. Thank you.
Yeah, thanks to all of the speakers, and I'm sorry that we're as late as we are, but we do have a few minutes, and it'd be great if we could get some questions that are relatively short to answer taken care of before we break for coffee. So I'll start with the front table here. And Peter?
Last year we did focus on the Northeast and the North Atlantic right whale, and you know, one of the elements of that, and it's related to ropeless gear and other gear, is kind of the distribution and abundance of pots. And I'm just curious, in the Dungeness crab, you know, what's the density of gear on the bottom? If you go to inland, you know, inshore Maine, it's carpeted with traps. So I have no sense of what the density of Dungeness gear is off the coast.
If I understood you correctly, you're just asking about the density of the gear or the quantity? Is it? Because I couldn't
Like how
hear
much is out there, and how, like if you're fishing, is your competitor's gear right near you? Is it just carpeted with traps, or is it spread way out?
Right. Okay. And that is one of the issues that we are concerned about. Is basically we can't tell where the other person's gear is, and we are many times right on top of each other, within maybe 4 or 5 fathoms of each other, and it is really honestly a problem. The other issue that we have with the ropeless gear is that when we set our gear, we set, like for instance myself, I'll set as many as 150 to 180 pots in a string, and each time we set the gear, we need to be able to see where the pot is. So as we're throwing this gear off the boat, we don't know the distances. And so that becomes a complication also. But yeah, that's one of our concerns is the fact that the gear could be on top of one another and be quite a mess.
Can I just,
Sure.
sorry. Just to maybe add that the California Dungeness crab fishing, the fishery has a trap limit program, and so I won't have these numbers exact. I can follow back up with Dennis and make sure that we have these right. But there are about 500 active, in between 450 and 500 active permit holders, and those traps, their trap allocation ranges anywhere from 250 up to 500 traps per permit holder. And so I believe that the maximum number of traps, if everybody was fishing, which it doesn't happen, but they're, if everybody's fishing every single trap, that it's about 180,000 traps in the fishery that exist. And again, I will double check those numbers to make sure I'm saying them right, but that's in general, just quantity-wise to add.
Is that just California, or is that coast-wide?
Just California.
Okay. Francis?
Thanks. Just a quick one for Dick to follow up on that. One thing that really struck me was the distribution of your fishing effort and the shipping lanes. So, obviously we're trying to minimize whale deaths, and another active issue for us is, how to minimize ship strikes. And one of the sort of adaptive management processes sort of in the works is how to move a shipping lane in response to whale distribution. So I was curious, obviously where you put your pots is driven by presumably the efficacy of previous days fishing and the season and what you know, but do you consider the shipping lanes too? And if the shipping lanes moved, how does that affect your effort and where you go?
We will fish alongside the shipping lanes, and I do know that if I'm not mistaken, they actually adjusted the shipping lanes for the whales here off San Francisco area. We fish right alongside them and in the separation zones, quite frequently. So. I don't know if that answered the question.
So you are actually fishing right in the separation zone?
Yes.
Sam? And
This is perhaps a quick question for Jeff. For the aerial surveys for the gear and the whales, did you envision repeating those surveys systematically, given the dynamic nature of both?
Yeah. Can you hear me now? Okay. Thank you for the question. Yeah, I think the general idea is trying to actually figure out where over the course of a season makes the most sense. I think what we learned in the last season is that having an aerial survey done as close as you can to right before the season opens to help inform are there whales still around in certain areas? Because generally the idea is that around the time of the season opener in early November, that's generally the time that the whales are leaving for the breeding grounds. But sometimes, like we saw in the last year, whales are still hanging around in high densities and don't leave till December, for example. So early on in the season, like a preseason evaluation, and then we've talked about doing something systematically, like maybe a mid-season and a late season, and do that in a kind of more regular fashion. And in addition, as Kelly described in the RAMP program, in cases where you do see some evidence of elevated risk or high levels of entanglements, actually doing a more targeted aerial survey at specific problem areas based on something that's actually happening and something that is concerning. That was the general thinking. And so one thing that we have talked about is looking for more of a sustained source of funding for this. We've looked at, for example, Section 6, Endangered Species Act funds that could be used to help better look at whale and turtle distributions, and then adding in the crab trap information to that would be, I think, a way that we're envisioning this. But they're obviously very expensive, but ultimately, I think probably the best in terms of finding where the whales are in terms of the data that we've seen so far.
Sam?
So just a quick follow-up, that's the sort of temporal element, but did you find that the resolution was fine enough sort of spatially to really inform your decisions?
In terms of the resolution, there's kind of this trade-off between how, if you have like 1 or 2 days of time, and it's often difficult to plan these. We had a lot of problems with aerial surveys the first year we tried them because a lot of the windows that we wanted to go out, the weather and other conditions just weren't there. But there's kind of a trade-off between what scale or how close together the transects are. I think that what when you're looking at kind of the more coarse view, you can spend that effort to go for the entire Central Coast. I believe the aerial survey they did was over one day, over the course of several hundred miles of coastline, versus when we did it, we just looked in Monterey Bay at very targeted, very narrow transects that were, I believe, about a mile apart in distance. So the distance and the spacing, there's basically the trade-off there between how much coast you get versus how fine scale you can get as far as that. But I think that in terms of just understanding the overall spatial arrangement of the traps and looking specifically, I think one of the key questions is where are the depths that are being fished, and are those the same depths that the current whale forage happens to be at? That's really, I think, a larger question, and you don't have to have as fine scale in order to answer that question.
Okay.
Maybe I could just add, and this again may be a bit more qualitative than not, but one of the things that has been, I think, really successful in the pilot is increasing and building networks of communication. So acknowledging that this aerial survey has the opportunity to be further informed by on-the-ground information. So that's through conversations with fishermen as to what they're seeing, conversations with whale watch operators as to what they're seeing, starting to bring in quantitative information on that level too, and overlay it. So again, it's in its initial stages, but trying to find various pieces of the conversation.
Okay, we're at risk of wide-scale mortality for lack of caffeine, but I have two more questions, and let's try to make both the questions and the answers as concise as possible. Aaron, please, first. You sure? Don't. Okay. Sue?
I think it's a quick one for Karen. I was just wondering, in terms of attributing the mortalities to stock, whether the increase of 11,000 photographs will include photographs from that Central American group. In other words, will we get better there?
Yeah, there definitely are quite a lot of those 11,000 that are from the Central California area, yes.
And on the same topic, here I am breaking my own rule. You have this working group working on the genetic ability to identify a dead whale to stock. Are you optimistic about that work?
I am fairly optimistic. Based on just the 400 base pair data that I showed from Scott Baker's lab, we can get, within the California and Oregon, we can get about 80% correct assignment to either Mexico or Central America. And what we're going to do is expand that to the full mitogenome, which is 16,000 base pairs. So I think we will be able to substantially increase our. I think it's still going to be probabilistic. We won't be able to say 100% this animal, but we'll be able to say with a very high level of confidence.
Okay, great. And you're going to break it too. Go ahead, Daryl.
Yeah, this is also for Karen, and following up a little bit on the stock identification and definition. You indicated that there's currently a moratorium on defining stocks. How long has that been in place?
At least 6 months, but I think closer to a year.
And you said you don't have any idea when that might be completed.
No, they're working on the policy, but that, as last I spoke to the person in charge, it was going very slowly due to lack of personnel resources. So I don't expect it to be quick.
Okay, thank you.
Sounds like that might be something we want to pick up later on. We'll have a panel session after this for 45 minutes, and we will get into some of these subjects and hopefully a few new ones with a couple more people on the platform. So what do you think, Daryl? We should probably still be back at 10:30 because surely we can get our business done in 25 minutes, okay?